Hello, good morning. Thanks so much for joining me here in my shop. I'm going to be doing a little tube testing after what happened in yesterday's shop session, which is on yesterday's video, concerning this tube here, this guy here. Just so you know, I do have an idea about exactly what's going on here, and I'm going to say it because I didn't really say it clearly in the last video. And I mentioned that there's kind of an effect here, which you can see in the last video, that I've noticed in many different circumstances while I'm working on radios. And what I've always concluded, and to be specific about what it is, I was touching this, I was using a metal, this is a piece of wood, I was using a metal tool, just touching this contact, and sometimes with essentially zero mechanical force whatsoever, just touching it causes a change. So how does that happen? So I think what's going on here is the contact between the top of this and the tube is poor, even though I've tried to clean it a couple of times, and even though wiggling it like this sometimes make you think it's either totally disconnected, never connecting, or it's connected, never coming loose. Because you'd expect this to crackle. Now the radio's not on while I'm doing this, by the way, so don't expect any result. So what I think is happening is between the contact of this and the grid cap here is an extremely thin layer. You can think of it this way: there's millions of potential contact points in here, under here. Who knows exactly where the contact is occurring? I kind of assumed it was along the edges. These edges, in fact. Now I'm looking at it, you know what? It would be more likely this edge. Maybe I've been filing the wrong areas. But in any case, you can see the corrosion on here. You know, this is a piece of steel, I'm pretty sure. They use steel for these things because they have a springiness to them. The other metal options for making these clamps is poor because the metal has no springiness to it. So steel is good, but steel is bad because steel rusts. So how do you fight rust? Well, you can cover the steel with zinc. So probably this is a galvanized steel piece here. That used to be a corrosion technician, by the way, and I usually don't go into these things very much in my videos, but there's a lot going on inside my head that I'm not really revealing clearly, so that's what I'm trying to do now. So when you first zinc coat a piece of steel, it looks almost like this. It looks almost like it looks now. Zinc has a bit of a grayish look to it and that, but initially it's zinc metal. Zinc metal is conductive, I'm pretty sure. So you can slide this zinc covered piece of steel on top of here and make good connection. Now let the years roll by, tick 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 tick, and the zinc has now corroded a bit just from the air. Air has oxygen in it, other active things. There can be, believe it or not, chemical molecules in your house floating around from cleaning fluids, all kinds of stuff floating around, years and years and years of that, and you get corrosion occurring. Zinc rusts. Zinc rusts into a whitish powder usually. I don't see really a whitish powder. But this could have happened so slowly over such a long time that in fact the zinc rust here is pretty thick. The zinc rust is not conductive. So you end up with an extremely thin layer on the surface of the zinc oxide or zinc something like that, some salt zinc. So thin, in fact, maybe only in places layers of atoms thick. Incredibly thin, in fact. You know, this is what goes on with stainless steel, by the way. In fact, this metal here, this is probably nickel containing metal of some sort or something like that, and it's an alloy, and it's produced the same thing that this is produced, except see how shiny that is? Shininess like that comes from the electron cloud that's floating you know, adherent to the surface of this metal. You see, there's a little bit of shine over here. You can see the reflection of my stick. A little bit of shine, a little bit of electrons sticking through here, the electron cloud, to give you that metal sheen look. In the case of stainless steel, the corrosion layer is only atoms thick. I don't know how many, maybe five layers thick of atoms, and the electrons from the metal in the electron cloud, you know about this stuff, it still poke through, still come through. come through in places anyway. And so you can still make contact. So stainless steel is corroded even though it looks shiny. And if you bring electrical contacts up against stainless steel, it'll make contact because the electron cloud is available. Well, this thing, well, it's got some corrosion layer on it that is thick enough. Well, I take a wild guess. 50 or 100 atoms thick, I don't really know. At some point, the electron cloud cannot make it through anymore out in here. There is no way to bring the electron cloud. Where's my, here we are. Let's say a probe like this, again with shiny metal. It's a special alloy to make sure the corroded surface, all metals are corroded except for gold. Okay, they all have corrosion on the surface, except for gold. Well, maybe there's a couple others. Maybe platinum doesn't get a surface corrosion, but everything else does. Even though it may not look like it, it does. So you bring up your probe, the electron cloud in the probe is available, but when you lay it up against this, the electron clouds cannot meet. They cannot meet, and therefore there can be no conduction between them. Okay, so now what's happening? And now I'm ready to give. This is my explanation. Okay, I'm making this up. This is fake technical news coming here. So I think when you bring a probe up, the probe has a touch of a charge on it inevitably, or perhaps this has a charge on it, some coulomb in there or something. And when you discharge it or charge it, even a tiny amount, that can cause literally I'll use a crude word, a spark, to pass between here and here, some kind of overcoming the ever so slight resistance of the very thin film on here and establishing a contact, electrical contact, essentially almost like it's welding the two together, but they're certainly not being welded. A little like that. That spot then can become conductive. So what happens is you touch and all of a sudden it comes to life. So I've seen this in a number of circumstances throughout my life, these mysterious things. There's another one in this radio, and guess what? It's the other tube top. Now I didn't say anything, but I touched this at one point just ever so lightly and the radio operation changed. Look, it's the same thing. It's another plated steel contact, except see, this one is shaped so that there's a chance for a lot better chance for contact in there. See, this is shaped for a large grid cap. The grid cap on this tube is small, and so just like I did, the cap has been pinched down. Sorry, I'm blocking the light. It's been pinched down, and that pinching has resulted. Actually, it looks pretty good. I was going to say the pinching has resulted in very small amounts of surface area contact in here, interfered with by the corrosion effects I was telling you about. Believe any of that? I don't know. But I'd just like to tell you, that is what's in my head about these things. You can see how long an explanation it took, and that's why I skip over it sometimes when I'm doing a video, because I say to myself very quickly, that's a 5-minute or 10-minute story, and I don't want to tell it because I'm already half burned out here in my shop. Now, here's the deal. Yes, I have my venerable tube tester here. We're going to be testing that tube. Let's go back here. We're going to take it out. Because another possibility here, although in my testing efforts, I kind of concluded it's very unlikely, is that there's a problem with the internal contact into the cap. And in fact, even though I'm touching it ever so lightly, I'm really affecting something going on inside here, the solder inside here. Very unlikely. It's really quite like, I mean, there's a bundle of solder on top of here. You can imagine that wire coming out, the guy soldering it on and then trimming it off, and then a little bit of sanding there. You can actually see the sanding marks, or the file marks where he buffed it off. It's very unlikely there's a fault in there. Could be some other contact problem, or maybe even something wrong with the tube. I don't get it. But the way out of this is to put another tube in there and see what happens. So I looked through my tube collection. I couldn't find any like this. This is a Rogers tube. I think these were only made for a short while. They have a metal surface on them that's been sprayed onto the glass. I think these very quickly were beat out by this type of tube. Look, I looked through my tube collection. I've got six 6K7s, but they're not this style. They're not the Rogers sprayed on metal style. These are your classic. I better leave them all in the bag here, because I'm going to go through these one at a time. So start 6K7. Who knows what condition this is in? There's the missing pin. Internally, this pin number 1, is almost certainly connected to the metal can. And by the way, if you didn't know it, there's a glass tube under here. The metal is not holding the vacuum. There's a glass tube inside here. The metal is protecting the tube and shielding it super good. I think these are very rugged tubes, or so they feel anyway. So I'm going to test these guys out, see which ones I've got that are working. I'm going to pop them in here, one at a time, or get rid of both of these older Rogers style tubes. Rogers is a electronics firm in Canada here. You're watching this from other parts of the world. Rogers is a very common term used in Canada. Everybody knows Rogers Cable, certainly in this part of Canada. Rogers Cable is the company that provides our TV cable. Same company, just if you just crank the time back, you'll find that company making tubes and radios and stuff like that. So they got into the cable game very early, and now they are one of the larger corporations, I'm sure, in Canada, serving cable to, oh my God, I don't know how many millions of people. 15 million people. There's only 35 million in Canada, 36 million. So that's why a Rogers tube's going to end up in my shop, because I'm in Canada. Patented, Canada, 1922 to 1944, it says there. This was probably Rogers' attempt at, breaking into the tube market with something fancy, and unfortunately this thing beat it out. Who made this one? This is made by Marconi. Hey, that's good. Marconi, but it says Radiotron. So when it says Radiotron, it's a hint that it's coming from a Canadian manufacturer, made in Canada, who in the background was making tubes to be branded by the larger companies. So I think this came out of a Rogers factory. But this came out of the Radiotron factory, made for Marconi to their standards, to their satisfaction. We'll go through them all and see what I can come up with. So that's what we're going to do. So I think maybe we're going to start with the Rogers one here. 6K7. There's a 6K7 right there. Okay, let's go through it. The unit's not even turned on yet, so get this out here. Oh, this has a grid cap, so we gotta use the grid cap now. Unfortunately, my tube tester has two grid cap spots, a plate cap, which is not very common, and a grid cap. You see the word grid kind of appearing there a little bit, but unfortunately this clip is gone on my tube tester. I just have a piece of wire I got sticking out here that I clip onto. So, did I have another one in here? No. Phooey. So I'm just going to use a clip lead to clip onto this. Since I got my tail burned so badly by clip leads there the other day, I'm going to check and make sure my clip lead is leading. Good. Bit of a long wire now. Okay, I think we're ready. Continue on. Yeah, I really should put a new. I've got these things in my shop. I could put one in here if I just wasn't so preoccupied doing everything else in life too. 6.3 JR 0347 0347 with a 5 on the end, 19 for the bias, 66 on the English. Press P4. So 900. Put the cap on. 900 on the meter. So we're on 3000 scale. 900 is going to put us right up in this area. Don't worry that it's in the replace part because we're on the scale setting here, not the English. So around here should be okay. I think I tested this tube previously. I think one of these showed up a week and the other one showed up okay. I can't remember now. I know there were no tubes that were terrible. I remember that. That's all I needed to know at that time. Put that guy in. Stick this cap on. Shorting. Good. Good to go. Here we go. Give it a moment here. And now a small statement by me while we wait for this to warm up. Attention all Americans watching my video. Your government's going to lay a tariff, I'm sure you know that, on certain products. I think they're going to spread around being lots of products. I just want to say that regardless of what the president says, Americans pay the tariff. Okay? I watched him last night on the TV giving his rally, and along with many things he said which were less than accurate was the statement that foreign countries pay the tariff. No, American citizens and businesses pay the tariff. It's an internal tax designed to control your behavior. You can agree with it, that's fine, but it needs to be looked at for what it is. It's an internal tax. The tariff goes to the American government and it's paid for by Americans. And it's just to keep you off certain products and force you to shop differently. So look at it that way. That's why people hate these things in the world. Okay, here we go. I only said that because your president is suggesting that tariffs are paid by foreign countries. It's just not true. It's just not true. Okay, so we saw no shorts. Now I got to calm myself down. You see, I really shouldn't do that. I really shouldn't talk about stuff like that. Before you click the thumbs down button there, just slow down a minute, okay? I'm just trying to be helpful. Here we go. B4. Okay, so that's well above the rating. If we flip this to English, we get a slightly higher, but it's in the good. Okay, so I think the tube is good. Hey, let's poke around with it a bit here. I can't imagine that this is going to make any difference. I'm sure this tube is actually... Oh, what was that? Who knows, right? That could be all kinds of stuff. That could be... That could be my... sit here and troubleshoot my little wire. Oh, this is probably what it is. That's the trouble with trouble. There we go. That's really working good now. Yikes. What's up with my wire there? Well, here's something else I got to work on. Have to be very careful. Yeah, anytime I test a tube and it comes up bad, the first thing I do is I doubt the test. I doubt the test. I don't just go, hey, tube bad. A lot of the time, test bad. So this guy's good, but I want to put a different tube in that radio as a matter of testing it. Plus, frankly, those Rogers tubes are scarce, and these ones not so much. So here's the Marconi guy. I have no idea the condition of these tubes. Okay, watching for a short circuit inside the tube. Okay, oh, the light flashed barely. Flashing light just means charges are moving. Doesn't mean there's a short circuit. It's a kind of weak flash. Usually the flash is stronger. Oh, maybe I don't have the cap on. Let's try that again. See if that flash is stronger now. In the range of normal. Here we go. We're on looking for 900. I'd say nothing wrong with that tube. So that's a possible candidate. We'll put the possible candidates to the right. put the impossible candidate somewhere else. Check to make sure it's a 6K7, yeah. So this is another example of how I store stuff, because if you're going to do this kind of work, you end up with a collection of everything. So here I've put all these similar tubes, 6K7, into a bag. And then the bag goes into a small bucket with loose tubes and other bag tubes. And so what do I put in the bag? Tubes that I have many versions, like many of. So here I've got 6 of these, so they go in a bag. That's how I do it. I have a bag this big of 6 AL5 tubes, just a huge bag of it. Okay, here we go. Okay, you see in the flash, which is reassuring. It's another good guy. Okay, you can join his brother over here. On to the next one. (6K7) Radiotron USA. This one's made in the USA, so I guess Radiotron was operating in the States. Also, of course, Cunningham on the bottom. Never seen that. Oh, we didn't do the short test. Shame, Jim. The risk of putting a shorted tube in here, like for instance a short between the plate and the heater, is when you push the button, blow up the tester. So this is done to protect the tester. Do not want to apply voltages to bad tubes. Another good one. And that's another thing. From my experience, and I think the experience of anybody who's done a volume of this kind of work, the tubes are actually very reliable guys. The only tubes you really need to worry about, the tubes you should worry about the most are rectifier tubes, output tubes. And why? Because they are pushed towards their limit. Because they are hard-working tubes, and they're designed to be as cheap as possible, cheap as reasonable. Yet they're working hard. So guess who gets beat up? Those two tubes. The signal tubes, like this one, they aren't working hard. But what I mean by that is there isn't a heavy current flowing through them. They aren't running hot. Output tubes are bigger because the heaters are bigger. There's more heat in there to allow a heavier current to flow through. Not so with these signal tubes. Another flasher, just like the others. They're all coming up almost exactly the same on here, right? Makes me wonder now, have I got everything set right? Let's just fool around with the bias. So you see the bias sensitivity is really great. I can drive it down to where it's supposed to be there. Right? 9, between 915, 1450. So let's put it back to where. So let's see if we're up around. Well, see, we're even over 1450 on that. That's 1560, that's 1700. It's okay. It's okay. And a tester like this, to some degree, what I'm looking for is a go, no-go. Like a open heater type tube or something like that. With the hot tubes, the hard working tubes, the output tubes, and the rectifier tubes, they wear out. So you can put them on a tester like this and they'll show low. These ones are more go, no-go type stuff. And of course, everything I say you need to take with a rather large chunk of salt. So this one's showing a little weaker. Now, I got this right back to the right spot. 19. Yep. So this guy's actually weak. Let's put him on English. So you see, he's hanging on. He's hanging on. So that would probably work just fine in 9 out of 10 applications. to some degree the operation of the tube is constrained by the components around it. It's like driving a car at half speed. Lots more capacity in the engine. You wouldn't even know it though unless you actually take it there. Now, does that make sense what I just said? I don't know. This is loose. Something loose in that tube there. I'm not sure. Down here in the base or where. Here we go. Okay, I see the flash. That's the best one of the bunch, according to how high up the tube tester goes. So I have a plethora of good tubes here. While we got the tube tester going, I'm going to test this other Rogers tube. I think I'm going to remove these from this radio and put in the other ones anyhow. Because as I said, these are scarce. These are a little scarce. You can see the metal contact that's supposed to contact this. It says good. I think the base is cracked here. It's not very reassuring, is it? It's another good reason to get rid of it, maybe. You've seen the pilot light flash briefly. That's. I'm gonna be able to get that on there. I'm not. Okay. Nothing like a challenge in the morning. You need a big honking clip lead here. Hear me rifling through my drawers in order to find something like this. Okay, there's the flash. Wow, all these tubes read almost exactly the same. Too many changes at once. I'm going to put this one back in the radio. But we're going to switch to one of these good ones here. This is a Cunningham. Oh. My plans are totally foiled. Ayah. There's a collar on the... Oh my gosh. Okay, so you know, Mr. Murphy has shown up as expected. Thank goodness gracious, all these tubes are identical, aren't they? And none of them are going to have a smaller base. They're all perfectly identical. Oh my gosh, my plan of action has been stomped on. What did I do with the Rogers tube? Yeah, look at that. Not by much, but slightly smaller diameter. Now what I'm going to do. I'm pretty sure there's nothing wrong with this tube. I would like to retire it from operation. because as I said before, it's a bit of a rarity. I think I have an option here to remove the collar. And I see the two screws there. Right here. What's underneath? What's in behind there? Okay, radio is not on, that's for sure. So I'm looking for the... Ah, look what it's got. It's got those square, little square fellows on there. Well, there's no reason why I can't loosen those off, drop the collar off the top. Don't need the collar, I don't think. Why the collar? Why the collar? Is there a collar on the other one too? Yeah, there is a collar, but it looks different than this collar. Is there a collar on every tube? No. I can't see what I'm doing there. Look with my eyeballs. No collar. Oh, see, and this one here has trouble too, getting into the socket all the way because of these pieces, which I'm going to deal with now. So, how am I going to deal with those? It's riveted, so I will probably bend these right off and break them off. Okay, chances are the original 6Q7 was a glass tube with a metal shield slid over it, and now it has a properly shielded metal tube here. It doesn't need this. Yeah, so I'll probably just bend those until they break off. I bend them flat and leave them if I could. Okay, you can bend these things once or twice, they break anyway. But if I bend this one, it'll be sticking out here. Well, it doesn't really matter. That's what I'll do. I'll bend them flat and try to leave them in the radio. You can set that down. Okay, what are the dangers of trying to take this collar off? It's not just a collar, it's somehow attached to the socket. No, it really looks like a separate metal collar. I tried to take these screws off, and I can't because they're rusty. Well, we'll find that out. Yeah, I think this is a pretty low risk operation. A little bit of a struggle putting the nuts back on from underneath. Is it worth doing? Yeah, I really do want to get those Rogers tubes out of there. Okay, that's the deal. Okay, I gotta stop for a minute, clear up my bench. I need more elbow space here to carry on. Or, you know what I'm gonna do? I think maybe I think I'll carry on. Let me. Okay, here we go. Peanut, stop peeking. Come on. Come on. Peanut. Peanut. I see you there. I can see you. You're not hiding. Yeah, what? He wants me to come out of the shop. Probably let him out of the house. Peanut. Come on. Show your face. Come on. Come on, little guy. Actually, he's a big guy. Stop playing games now. Come on camera. I see your little ear there. Peanut. 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 Come on. No, he says. Oh, he's coming. He's coming. I convinced him. What is the problem? What does he want? Come here. You want to go outside? Is that what it is? This is a wonderful cat. Yes, you are a wonderful cat. But see how big he is? Man, if he jumped on my bench, it would be a disaster. Hey, what's with the camera focus there? Okay, Peanut, I'm going to go to work here. I'll let you outside in a little bit. I said okay, I'm going to go. He thinks I said okay, I'll let him out. Peanut, Peanut, do you want to go outside? Peanut, attention, cat. Oh, he's distracted now. Peanut, Peanut, up here. Yes. Do you want to go outside? That's the answer to that. Well, you couldn't see that. Okay. Peanut the Wonder Cat. Okay, give me a screwdriver here and we'll just kind of get right into this, see what happens. Let's try this one. Hey, I've had the screwdriver for 40 years or more. Okay. I don't know if that's in far enough. Oh, it's loose. It was loose. It was loose. It was loose. What's that mean? I don't know. Stick my finger back there. I don't think it would affect the radio's operation at all. Okay, I'm on. Got my finger on the nut. Oh, I see my other cat has come down. That's probably really what Peanut wanted. You know, it'd be great if I could kind of hold the nut with my finger so it didn't move. That's not going to work. I was going to say then I could just have the nut right in the right spot to put the screw back in. But, wow. I'm trying to use the eyeballs on the end of my finger. Oh, a nut. That's loose too. Quite loose. Okay, now this one I stand a chance of keeping the nut in the right place. Putting the screw right back in. Uh-oh. How am I going to do this? I got my... do it by hand. By Jove, I think he's done it. Yep. Wow, this turned out to be easy as can be. This one won't be so easy. Okay, that was pretty tough to get it, even the thing back in there in the right spot. Okay, so I gotta have my finger kind of like this. Good luck. Good luck here. I think you're going to hear the sound of the nut dropping as I... Well, that was the sound of the nut dropping, so that's not going to work. Okay, so amidst all these wires stuff. Very unusual to find a square nut inside something like this. Make this easier, I'm going to put the screw on this tool here. There we go. I think it's a lot better. A lot better chance of success. Okay, put it through. Now, see it? Can I get there? I just twisted that screwdriver, popped off. Okay, we'll try a regular screwdriver. Back to square one here. Okay, screwdriver's in. Ah, I lost the angle. Almost got it there. Okay, in on the screwdriver. Bingo. That went off pretty good. Okay. Call her out. Swing this around. Tangle up here. Okay, I think we're ready to try now. Grab a goodie. Get one that looks just a little better than that one. Ah, nice and clean up here. The same grit cap, so a little lower down now. Now let's fix this tube here. So I'm gonna just bend this tab out. And likewise the other side. Just bend her down. See if the tube goes in better. Yeah, now it goes in. Okay, so I still got the original one here, an alternate one here. I give this about a 15% chance of resolving the weirdness problem here. That's what I say. Okay, we're ready to turn them on. Let me just check a few things. I have a high voltage connection back here. Didn't I have the other scope back there? I do, but for now it's just here. That's okay. So we are clear. Oh, and one more thing. This is where the SDR doesn't have to be in right now. We're just trying the radio. Oh, my clock is behind. It's actually not 9:17 today. It's 10:17 because it's time to switch to standard time. I think we're good. We'll know momentarily. Yeah. Jesus, it scared the heck out of me there. I'm just convincing myself the radio wasn't working. But it is. It's warming up. Curious sound. That's curious stuff there. Why the radio does that. It's not very reassuring. I'm standing perfectly still here, just watching it. I don't know, you think that's an improvement? Okay, let's see if we can figure out what's going on. I mean, the obvious suspicious thing is this guy right here. You know, I'm bumping some wires up here, but I don't think it would actually cause a problem. Okay, is it that? This radio just won't give up, will it? Touching the cap causes an effect. That's a pretty strong indication the cap is communicating with the tube. What is the psh sound? Kind of sounds like the antenna coming and going. What about this guy? What about this guy? Isn't that? Is that the thing that's making the noise? Doesn't seem to be. Well, I've exchanged one weirdness for another. I'll stick an antenna on it. That's pretty interesting. So right now the antenna is connected to the two scopes. Right, to two scopes. Scope inputs 50 ohms. It's just basically shorting the antenna out. So when I disconnect it, the yellow wire becomes the antenna. Turn it down. Sounds pretty nice. Now, this radio worked great with a loop antenna, but I'm just going to stick a piece of wire on it for now. Thought there was a stronger response. Really? What? get one foot of wire versus another 10 feet. I think that would make a big difference. Oh, the mysteries of it all. Let's go tuning here. Lazy way to tune. And faded right out. Oh, what is that? Right around 640 where there's a station. Tell you what I'm going to do. I'm going to hook up that loop antenna, and because I'd like to compare it to what happened before. So let me put this connector on here. It's kind of awkward. There we go. Okay. Now, the loop antenna is just behind me here. Not doing this late or in the evening. We're doing this at a bad time of day. Okay, that's what I'm talking about. Loop antenna. Okay, just in there. Very impressive, was it? Turn it up. There we are. Okay. I was just tuning the antenna now. Everything's ready to go. Let's see if we can find 640 on here. Oh, antenna's turned absolutely the wrong way for that. How do you like that, eh?
That they're thinking about you, and even though they're taking
here's what I did there. Antenna's like this. They just turned at 90 degrees.
So, but we are noticing that in the broker community, that a lot of their clients are coming to them and saying, look, I want to own physical precious metals, and then those brokers are coming to us and we're showing them how to do this on a long-term basis.
It says in this article, in recent years, I've seen an increase in those same professionals seeing the writing on the wall, foreseeing a crash in the markets. A common comment is, I provide my clients with a diversified portfolio, except the truth is, it's diversified within the markets themselves. I don't provide them with anything outside the markets, so if the markets hit a wall, my clients stand to lose it all. That's not true diversification, and oddly enough, you mentioned Ibbotson Associates, right? To the back end of this, I actually printed off a little bit about that, and we did that without knowing it. And of course, I draw upon this in all the seminars we talk about all the time, and it is a major study.
So here's what I'm hearing. So here's 640 that we're listening to. These are the side bands coming out 5, 6, 7 kilohertz on either side. Now you want the radio to tune like this, to not start too soon, but catch the important stuff. Go like that. And then you're going to hear the highs and the lows. The lows are right in here. What I think is happening in this radio is the tuning is actually over here. Now what we're doing is we're grabbing one sideband, mostly, and really what's happening is the radio is tuning these higher frequencies in the program material that it's sending, which is why it sounds, you can really hear the highs, it sounds really clear, it sounds like there's no bass. This may actually be so far over as to actually be capturing just over here even. And you'd get all the highs, but you wouldn't get the bass, which is in here. Why don't I just retune the radio and just bring this into the middle? When I try to do that and get that full, rich tonal sound, this is acting a little weird. I'm about to undo my explanation.
Whether it be precious metals or colored diamonds.
But just to get back to the people that invest own their own homes.
So when I tune for the highest, strongest signal, it's like there.
To say, shall I buy this 5-bedroom house?
But the warmest sound,
or shall I buy a 2-bedroom or 2-garage, 3-bedroom townhouse?
is down
made
here.
up their decision. They looked at their budget and they went
Louder,
and said,
with treble,
we can't afford this, but we're paid a little
better
extra.
sounding,
It's the same thing with gold and silver. I don't know
a little less
how many
volume.
people have bought gold and silver and snuck home and not told anybody about it. At $35, gold at $35 an ounce and silver at $2 an ounce.
So you can definitely hear the tonal quality of the signal improves as I tune away, as I'm starting to tune away from the peak.
He ranted on about Warren Buffett, who says, well, you can't
So it's not a question of tuning the radio from the big dial, it's some other tuning in here which is resulting in some shape or something about the response curve that it's not, it's like that. Hey, it makes sense to me. On the other hand, wow, sounds great, eh? It's a great sounding radio. Now, we're going to just go up to the higher frequencies, but I don't expect any more. Oh, beautiful. Okay, let me retune the antenna. Oh, this is working really well. Oh, did I say radio? Let me retune the antenna here.
Une ville de Russie, dans l'Oural, qui prône, c'est peut-être le personnage le plus officiel, le plus haut placé, qui prône le boycott.
That sounds fantastic.
De ce point de vue-là, de Vladimir Poutine. D'ailleurs, Alexis Navalny a été candidat à la mairie de Moscou en 2012, si je ne m'abuse.
Beautiful.
Mais là, cette fois-ci, on l'a empêché de participer aux élections présidentielles.
Il y a beau y avoir des manifs, des gens qui sont contre, tout ça, mais le taux de popularité, il ferait rêver à peu près n'importe qui sur la planète, là.
Wow, it's great.
Oui, oui, mais en même temps, vous savez, comme je ne sais plus qui a sorti cette blague en disant si dans un village, il n'y a qu'un seul restaurant et dans... Est-ce qu'on peut dire que ce...
What was that?
Oui, d'accord.
I wasn't moving.
Bon, alors oui, Vladimir Poutine est populaire. Ce qui, par contre, est une nouvelle. Bon, d'abord, sa popularité a apparemment baissé un tout petit peu depuis le mois de septembre, 5 à 6%, mais il est quand même à près de 70% de popularité. Et ce qui est étonnant, c'est sorti récemment, la maison de sondage indépendante, l'Evada, a sorti les chiffres sur les jeunes. Alors vous savez qu'il y a des jeunes maintenant qui vont voter, qui sont nés, qui n'ont rien connu d'autre que Vladimir Poutine, qui sont nés en 99-2000 et qui vont voter pour la première fois. Ils sont 1,3 million de jeunes électeurs qui n'ont connu rien d'autre que Vladimir Poutine. Mais pour revenir aux jeunes entre 18 et 24 ans, 86% d'entre eux sont satisfaits de Vladimir Poutine.
So now, my last time I tried this radio, as I moved into the higher half of the AM band like I'm doing now, it just didn't pick up any stations. Problem with doing this right now is there really aren't any stations up there to pick up. The antennas probably requires retuning. Tuning is extremely sharp on the antenna. Okay, retune the antenna again. Oh, something here. Right there. Right there. There. Now, is it there weakly because it's a weak signal, or is it the radio that's gone weak? So I'm up at the higher end here. 1500 and going up. The fact that it's picking anything up is pretty good at this time of day. Okay, better retune the antenna. Anything, come on, anybody. Wow, you know, this isn't the best time of day to be doing this. So, volume is fantastic on this radio now. Hardly have the volume control up for all that. Probably 5% of its travel. It's really, really strong stuff, which is fantastic. So it probably needs to be tested at night for me to really reach some kind of conclusion about its performance in real world operation. I could feed in test signals and compare them and do all that kind of stuff. I'm not going to bother with that right now. My question is, so what should I do next? Thank you for reminding me. So now that weirdness, oh boy, that could be this tube I put in doing that. Who the heck knows at this point? I sure don't. Boy, that's a little disturbing. Okay, so we'll ignore that occasional roar and keep going on other stuff. So what can I do here now with the radio? Test it tonight, which I think I'll do, and determine if it's receiving at the high end. May not be. I also noticed that my directional antenna lost direction at the higher end, or seemed to have no directionality. It's kind of weird. I don't know why that would be. Just another observation I made. I don't know if it's valid. And then after doing the test this evening, go back to the alignment process. I could do a by-the-book alignment again very carefully, and then examine it with all the instruments and see if things look lined up. I think we're really close. You know, this is only band number 1. There's 2 more bands to fool around with on this radio, and it's working really well on AM. Can't use the loop antenna for the higher frequencies. It's out of range for the loop antenna. It's designed for AM, the AM band. But that being said, should be able to get a piece of wire in here and start hearing some short wave, and I'm pretty excited about just how sensitive this radio is really going to be, because it has the double front end. It has 2 stages of tuning at the front end, right? It has a 3-gang capacitor. That makes it a good radio. In fact, I'm stunned sometimes at how well these things will work. Okay, I think that's it for today. Thanks a lot for watching, and we'll just keep moving forward step by step.